Okay, so where we stopped off yesterday was at question 2, and I told y'all to think on it. That we have this trinomial, z squared plus 2z minus 15, and we want to write another polynomial that has that same factors. So what can we do to get it to where that trinomial will factor and have those same exact x-intercepts? Where it's z minus 3, z plus 5.
Turn one into a positive and negative.
No, that would change it up because then we'd have them kind of, they're flip-flopped. One's farther out and one's closer in. Did you make any guesses?
Could you square it?
Not square it, but if you multiply it by some coefficient, it can either stretch it or compress it. So when you think about it, this is a basic parent function, and those stretches and compressions are going to make it stay going through the same x-intercepts, but be further away, be stretched out or pushed in. And so we could take some number, tell me a number, and multiply it through and it would become 5z squared plus 10z minus 75. And so this would factor, if I was to go backwards, back to, because if I think about this, the factors of this trinomial was z minus 3, z plus 5. So I'd factor back to that same base. It just would have a different graph view because it'd be more stretched. So this is a different trinomial in general form that has that same factors. And remember, they're using z where I was using the smiley face for the smiley face substitution. And so you'd have that same basic, and I call it the x-intercepts, but it's really not. It's where it would cross if it was in that standard of scale. Everybody ready to go on to the next one? Okay, so from the next shortcut, so we had the first shortcut was the chunking, where we used the smiley face substitution, and it had that same pattern where it was a square to the first, was a factor of the second term. Now we're going to do something called a perfect square trinomial. And I am sure that you love these letters combinations, and they mean the world to y'all, and it makes perfect sense to you like the book thinks. Would y'all like me to get some numbers in this? Yes, because that did not make sense whenever we're doing it that way. So let's do 25x squared. I'm doing this top one. Minus 60x plus 9. Nope, not minus plus 9, plus 36. Sorry. I forgot to write down my problem. So first up is I need to find out, can I take the square root of 25x squared? Can I take the square root of 25?
Yes.
What is it? Square root of x squared? Just x. How about the square root of 36?
6.
Okay. What I'm doing in red is stuff that you can do mentally. You don't have to show on paper and pencil. 5x times 6 is what?
30x.
If you double it, does it match the center term? Okay. So you square root the first, square root the last, multiply it together and double it. Should match the center term. Other things is this last term must be positive, and this first term must be positive. If they're both negative, factor out a negative. But if one's positive, one's negative, then it's not possible for you to use this trick. Doesn't mean it's not factorable, it just means it's not a perfect square trinomial. All you do to write your solution is what was the square root of 25x squared? What was the square root of 36? Drop your middle sign and square it. This is a shortcut to the box. All of the ones I'm teaching you today, all the first ones I'm teaching you are shortcuts to the box. The box still works. If you're frustrated, go back to the box. But this is a shortcut to the box. So if I gave you 49x squared plus 28x plus 4. Can I take the square root of 49x squared?
Yes.
And that would give me,
7x.
can I take the square root of 4?
Yes. 2.
What is the product of those two?
14.
I multiply it times 2. Do I come up with 28x? Yes. And so that means this trick is going to work. 7x and the 4, drop the middle sign.
So you're always just taking that 4 from the.
Oh, not 4. That was supposed to be a 2.
Okay, that's what I was thinking.
Sorry. So that's an example of the second one. Nothing different, just the sign's different in the center.
So how are they both the same? How would they both be the same answer? If one's positive and one's negative.
The middle sign is what's different.
Yeah, that's so.
So like,
How could it be?
if I had
Well,
7 minus 2x, or minus 2, 7x minus 2, it would come out to be 49x squared minus 28x plus 4. These would go together, those would go together.
Okay.
So they're not the same, they're just very, very close. That middle term is crucial to drop the right sign. Because signs matter. So I want you to take some time. I want you to think through these. There are 2 of them that are perfect square trinomials, and there's 2 that are not. B and C have an extra step that you need to do beforehand. Which one of those 2 would you like me to do?
B.
B? Okay, so on B, what number divides into 16, 40, and 100?
B2.
Bigger.
4.
4. So 4x squared minus 10x plus 25. And this right here is what you're going to look to test to see if it's a perfect square trinomial.
So it means that same thing for C2.
And C, you'll have to do the same thing where you take out something and then check for perfect square trinomial. Go ahead and see which one of these will work. So just in case you need to look at this beforehand, I'm gonna, this is a little cleaned up on the first column. Look a little bit nicer. So when we're dealing with the perfect square trinomials, the big things that you need to look for is the middle term must be squared of the square root of the, or squared, must be the double the product of the square roots of the first two, and the signs must be positive at the beginning and positive at the end. So which of these fails because of signs? A is not a perfect square trinomial because this would need to be positive. Anybody else fell? You can tell straight off.
D.
Well, what's the square root of 9x to the fourth? 3x squared. What's the square root of 1? And so as a product of these two times, so the product of those two is 3x squared times 2, does that equal 6x squared?
Okay, see, I didn't take
The squared?
4 to the square. Okay.
Yeah.
Okay, that makes more sense.
And so that's where that one,
Okay.
I can see that one tricking people up because it does.
See how, that does work.
And so the square root of something to the fourth power is squared, square root of something to the sixth power is cubed.
Yeah, okay. I didn't know that.
So that's a very good, I'm surprised the other people haven't been willing to voice that earlier today. And it is squared. And remember that middle sign came from there. Okay. So let's go ahead and take this first problem. What is the square root of 4x squared?
2x.
What's the square root of 25? So the product of the two of them is 10x. If I double it, does it end up here? So, not a perfect square trinomial because middle term isn't a product, isn't double the product of the square root of first and last. Sorry, I'm running out of room. Is my shorthand okay for y'all? Okay, so now let's look at this next one, C. What divides into all three of these?
4.
4. And that gave us 16x squared minus 8x plus 1. And honestly, on this one, you would have factored it out whether you did this step or not. It's just always best to check for it. And so you have the square root of 16x squared is equal to 4x. The square root of 1 is equal to 1. Their product is 4x. If I multiply it times 2, I come up with 8. So we have the 4, and then the 4x. The middle term gets brought down, and the square root of 1. squared.
So does it matter if you factor it down or not?
It would change what this is, and it'd make this an 8 and that a 2, and then you would have to factor it out again.
Okay, so it's just better to do it at the beginning.
It's
Okay.
better to do it at the beginning. It will make your life easier to do at the beginning. I know that they show you the steps on this one, but they make you explain what you're doing below. If you like colors, this is one of those things where you may want to have colors out to help you with factoring. So if we look at the first two terms, what can factor into both of those? What do they share? Think about them in the box. What would you have factored out? You'd factor out the x squared. Maybe do x plus 3. On our second two, what do they have in common? Well, if this middle sign is negative, it automatically defaults to being negative here. There's not a number that can divide into both, so we just put a 1. So if I divide negative x by negative 1, we get positive x. Negative 3 divided by negative 1 gives me positive 3. Do these two match? The two parentheses. Yes. So we're going to write them down one time, because when you factor something out, we only write it one time. And then we're going to write what's left over. We're not done yet, because this last one has a negative sign here. If it didn't have a negative sign there, we would need to stop and not be able to do this trick. There's another one that if it's cubed we can do, but you couldn't use this trick. We're going to see if the square root of x squared, if we can take the square root, we can. Can we take the square root of 1? We can. So that means that that is a difference of squares, because you can take the square root of both of them. So it'll always factor out like this. So identify what you need to show yourself on the steps, and those are the steps you need to write down. Now it asks us to identify the zeros of that function. So we had that was x plus 3, x plus 1, x minus 1. So it crosses the x-axis at negative 3, at negative 1, and at 1. So negative 3, negative 1, and 1 are all the places it crosses the x-axis. My leading coefficient is positive, so A was positive, and my degree is 2, or the second degree. That means I have a parabola. I'm either going to have a parabola up or a parabola down. Which one is it if A is positive? Up. So that means, oh, excuse me, not a parabola. I forgot what we're dealing with. I was thinking of another problem. It's not a degree of second. This is a third degree. So that means it's either one of those two, or can be one of those constantly rising or falling graphs. These two will come into play if it's the same parenthesis. So like if it's an x plus 3 cubed. We don't have that, so this is not involved. A was positive, so which one of these two is the right way? The first one. The right hand up. And since none of the factors have a power on them, you're always just going to cross through each time. I want you to do it for number 5. So check out your number 5 with what I have on the board. See if it matches. So Braxton and Kenny both factored out their polynomial expression over a set of, and analyze each set of factors of the student's work. Which one is done, which number set are they both done over? So are they on the real system or on the imaginary system? Or complex system? Do either of them have eyes involved with it, in other words? Yeah, Kenny does. So he factored his on the complex system, and Braxton did the real. Oops. So just kind of read how things, where they want you to stop. If they ask you to factor it over the complex number system, then you have to go down to the eyes. If they ask you to factor it on the real number system, then you get to stop. So that's just a matter of listening and reading what they need. If you're graphing it, they really don't need you to take and go it to the next step. But if you're not graphing it, you may need to. Or if you're going into the higher end graphing it where you're trying to find things, you'll go into the complex. So if I was to ask you to factor x to the fourth minus 29x squared plus 100 using the quadratic form. So we have that a being 1. So we can use the x, but we really don't have to go into the box. When you're doing this, if you take the square root of this first term, so that gives me x squared, that's my first thing that's listed. Now, I want something that's going to multiply to give me 100 that will add to give me a negative 29. So what two numbers multiply to give me 100 that would add to be 29? Think currency, think money. $25. So negative 25 and negative 4. So negative 25 and negative 4. I'm not done yet because both of these have a negative number here, or negative sign there. And I can take the square root of 25. So I'm looking for the difference of squares. Can I take the square root of x squared?
Yes,
Can I take the square root of 25? So the first one's going to factor out to be x plus 5, x minus 5. The second one, we've already determined that you can take the square root of x squared. Can you take the square root of 4?
2.
So x plus 2, x minus 2. I want you to do A and B. And then work on the talk. It is homework if you do not finish it in class. I hope to be able to go over A and B with y'all before we leave class. Or at least show you the answers.